Hello and welcome to today's Science Did You Know video. I'm going to be explaining an interesting fact about gasoline and ethanol ratings after recently learning about this topic in chapter 22 here, Organic Compounds, in this physics book here, which discuss topics like that. So at the gas station, you've probably noticed those three buttons, like over here, that show the ethanol ratings of the three different types of gasoline, 87, 89, and 91 octane. So here's the science behind these ratings. So there are two main components of gasoline, hexane and heptane, that make up gas. And hexane is the weaker of the two components. In the four-stroke cycle, you can see here, the gas that's in this blue area, if you say there's hexane in here, the gas gets ignited as it's compressed. And with hexane, this is a hydrocarbon, the way hexane is constructed, it does not provide as powerful a reaction when compressed and exploded as the other part of gasoline called heptane. So hexane is being ignited here in the four-stroke cycle. But if you say there's heptane in there, heptane will elicit a much stronger reaction when compressed and then exploded. So heptane allows for more power out of the engine, and it's also efficient and better for the environment. That's why there's a larger quantity of heptane typically in gas. And that's exactly what these octane ratings measure. Since the solubility or the overall environmental rating of each of the hexane and heptane components, hexane has a rating of 0 and heptane has a rating of 100. So this is the average of the two ratings based on how much of each of the components hexane and heptane there is in the gas. So if you have more heptane, this octane rating is going to get higher because the heptane allows for more power out of the engine. The premium fuel here at octane level 91 has a higher quantity of heptane. And these lower octane fuels, such as 87 over here, they have slightly less heptane and slightly more hexane. But typically, there's a much larger quantity of heptane than hexane. Because if it was like mostly hexane and gas, it would not be good for the engine. Even some vehicles, like for example, my dad has a muscle car, like this one, Dodge Challenger. The V8 in this vehicle requires premium fuel, in this case 91 octane, which means it has more heptane than hexane. If you were to say put 87 octane fuel in here, the engine would start knocking because the reactions in each cylinder are happening at different times. Because there's more hexane in there, which means the reactions are less powerful, which in turn leads to the reactions in the cylinders happening at different times, which causes knocking. That's why cars like these require premium fuel to prevent damage to the engine and to prevent knocking, and so it requires 91 octane fuel. More economical vehicles with less powerful four-cylinder engines require minimal octane ratings, such as 87 here, where there's more hexane. Because, one, the engine doesn't need to squeeze as much power out of the cylinders, and two, it would be easier on the environment. You don't need to put in premium fuel in a car that doesn't need it, although it wouldn't damage anything if you did it. So that's the overall science behind octane ratings and what they mean in gasoline. The two components are hexane and heptane. And that's basically what I recently learned about in this year's physics book about organic compounds.